Now we have completed assembling the hardware and connected everything up to the microcontroller. We figured out what value resistors to use for driving these transistors, figured out what value resistors to limit the current going into the segments of the LED, and figured out how to wire up the display to the microcontroller, and assigned what pins that we're going to hook them up to. So these are pins 0 through 7 for segments A through G, and then 7 is the decimal point. And then our digit drivers are this one. So this is the right handmost digit. I'm going to call it digit 0, 1, 2, and 3. And so they're driven by 8, 9, 10, and 11. And then over here is the analog input pin A0 with our resistor divider to bring the maximum 15 volts down to 5 volts for the analog to digital converter to work with. So now that we've completed the hardware, let's have a look at the software, or it's often called the firmware. It's the code that's burnt into the flash memory of the microcontroller, and it's the program. It makes this thing run. Now, microcontrollers, once they've started up, they're always running. They continually need to be executing instructions, and so unless they're put to sleep or otherwise stopped, but generally they're kept running all the time. And so they need to run in a loop, and they do the same thing over and over again. What they actually do inside the loop may change depending on the conditions outside, or depending on what the software does. But generally all computers, including your PC and your iPhones, your smartphones, etc., they all run in loops, continuous loops. And so our program here, to make this display work, this digital voltmeter work, is also going to run in a loop. Now, before we start writing any C instructions, C is the programming language, or C++ actually, is the programming language used by the Arduino system for writing our software. But before we start coding that, start writing the C instructions, it's always a good idea to design your software. And you do it without using the instructions. You can draw pictures, you can do what they call pseudocode, or just words for the instructions, or whatever, but you should design your software before you start writing it. Years ago I worked for a software engineer, and I learned a lot about software engineering through this guy, and one of his sayings was to me, when he assigned me to do some coding, some software writing, was that I want to see a spec. I want to see a description of how you're actually going to use it. And that's my phone. All right, back from the phone call. Let's get back to what I was talking about. The software engineer I worked with, he wanted me to not write any instructions, but just design, draw out in pictures or whatever, what the software was going to do. He wanted me to define all the variables and all the functions before I started coding. And his saying was that the sooner you start coding, the longer it's going to take you to complete it. And because you get buried in the details of the code, trying to figure out how to make a loop work or whatever. But if you do all the design ahead of time, and the coding part where you actually transfer or translate the the design of the or the algorithm of the code of the software into the actual instructions of C, is actually only about 10% of the whole job. So I encourage you to do that. Just look at what your program is going to do, and that way you get a feel for how it's going to run and for what functions and variables that you might need. So in the main loop here, there isn't a whole lot to do. We need to read the analog to digital converter. We need to read that frequently to get an idea of what the voltage is, or get an actual value of the voltage. We need to convert that value from the A to D converter, which is a number that is meaningless as far as voltage is concerned for what we want to see. So we have to do some math to convert that into a number that can be displayed that represents the voltage. We need to output a digit at a time of that data to each of the digits. So you turn off the current digit that's on, you output the data for the next digit, turn on that digit, and then go and you're going to have a pointer that tells you what digit that you're working with. And when you've turned on the new digit, then you need to update the pointer so it points to the next digit. And then you go back and do all that again, except you'll be working on a different digit each time you go through the loop. So your pseudocode might look something like this. First of all, here's the loop, or the function called loop. And so here's read analog pin. That's easy to do. Then you got to do some calculations to convert that number from the A to D converter, and I'll describe how to do that in a bit here. You got to convert that number into a value that's the digits. That means makes sense to us. And as I said, turn off the current digit, output a value for the new digit. And what I mean by doing that here is go back to the schematic. So we got one digit turned on, say it's digit 0. So this one's lit up. The information is driven out from the microcontroller to turn on or off the different segments to create the digit. So you want to display the next digit, you turn this one off, change the code here so that it displays whatever the digit is for the next digit, and then turn it on, and then go away and do some other stuff. And then the next time around, you turn that digit off, output the next code for the next digit, and turn it on. And you just keep doing that over and over again. And in between times, you read the analog to digital converter and do the calculations, etc., etc. So, and this is what these 3 instructions here are doing. And then, like I said, you need to have a pointer that tells you which digit you're actually working with. And so you've got to update that as well. So that's the loop. Now, before the loop starts to run, after the microcontroller is powered up or after it's reset, there's probably some housekeeping you need to do, and that runs once when the microcontroller starts. And you'll need to do things like you got to set up or initialize the I/O pins here. So I want to make all the I/O pins outputs, and I want to make them all the I/O pins high. In that case, it'll turn off all the digits. There'll be just a blank digit. And then some of the variables that you're using in this main loop here might need to be initialized as well. So this is your do once portion of the code, and this is the loop that runs continuously and infinitely. Now Arduino provides 2 functions for you. I'll get to that in a moment, that do this and this for you. You have to fill in the blanks, but there's one function called setup and the other one's called loop. Now, continuing with our design of the software, let's look at variables. What do we need to store information in? Now these are called variables, and they're put in RAM, which is called RAM, and it's volatile memory, which the values would disappear when you turn the power off, and then you turn it back on. You don't know what they're going to come up as. They're going to be garbage in those variables. So that's why you have to initialize them before you start using them. So let's look at this sort of a bit at a time here. So I talked about we need to store the value of each digit that you display. So 1 byte for each digit will work. And so I'm going to call them all display digit 0, display digit 1, display digit 2, and display digit 3. There's 4 of them all together. I'm going to say something right now about this code. I'm describing the code or the instructions or the software for this digital voltmeter in a very simplistic way. I'm going to develop and write the software using the minimal number of functions or features of the C programming language. There is a much better way of doing this, and in another tutorial I'll take this code that we've just written and I'll rewrite it and show you some more tips and tricks on how to program more effectively and more just easier to read and also less likely for you to make mistakes. So continue on. We've got the 4 digits now. We need something that tells you which digit we're displaying. And so we'll have another variable, a pointer to the digit being displayed, and let's call that one digit count. And it will be a counter, 0, 1, 2, 3, and then when it reaches 4, it'll get reset back to 0. And that's part of the code here, the instructions here, where I say point to the next digit. It'll update that variable there. We will need temporary storage for the raw analog value that gets read out of the analog to digital converter, and because we have to do something with it, we have to use it in a calculation to convert it into some numbers that make sense to us. And I just called it VRAW raw analog voltage. And finally, we're going to need another variable to store the result of this calculation where we convert the raw analog reading to a voltage value that we display. And we want to set it up so that it displays 4 digits. And I just decided to call that Vn because it's a representation of the actual voltage that we want to read. So this is the description of the variables that we're going to need. And the next thing I'm going to talk about is the functions that we're going to need. And let's just do this one bit at a time here again. So back to our setup, we got to initialize the I/O pins. And so we need to set the direction of the I/O pin. Is it an input or is it an output? In our case, the pins that we're going to play with need to be outputs. And one thing to remember is when the Arduino or the AT-Mega 328 microprocessor that's in the Arduino, when it starts up, when it powers up or when it resets, it automatically sets all of its I/O pins to input. And therefore, if you want to use them as outputs, you actually have to tell the microcontroller that I want to use that pin as an output. And Arduino gives you a function already. It's called pin mode. I talked about that earlier. So pin mode, number of the pin, and then what you want the pin to be, an input or an output. Also, we need to set the pin high or low. And in the initialization case, at the beginning of the our code here in the setup function, we want to set them all high. So Arduino also gives you that function. It's called digital write, and again I talked about it a little while ago. Digital write pin number and what state you want it in, high or low. Now the next one, we got to read the analog input voltage or the analog input pin. And again, Arduino gives you a function already done for you called analog read, and you put the pin number that you want to read in the brackets here, and it gives you the value. And I'll show you how to use that in the code. I think I also gave a very quick overview of how it worked in a previous tutorial, but I'll go into more detail in a minute here. And now, one more function that we're going to need is after we've done our calculation to convert the raw analog value into a number that represents the voltage that we want to display, we'll have in each of the digits a value 0 to 9, representing the value of the digit. But that number 0 or 9 or 5 or whatever is not, you can't output that straight to the display. It's not going to give you the digit on the display. You have to figure out which segments are lit and which segments are not lit in order to display a 0 or a 2 or a 5 or whatever. And so we're going to need a function that takes an input, which is a number 0 to 9, and sets up the segment drivers of the display. And so here, so it takes a number from 0 to 9 and it turns on or off these pins here in order to create the digit on the display out of the 7 segments. And so we'll create a function and I'll call it convert digit. And in the brackets here we'll put in the value 0 through 9, and it will display, it'll set up the I/O pins to display the correct digit on the display. And I'll go into detail with that as well when we start looking at the code. And then at the bottom here, I said, as I mentioned earlier, we have 2 functions that Arduino gives us that we can use at the beginning, setup and loop. So that's basically all there is for our software. I have one more thing to look at, and that is the calculations to convert the raw analog value into the actual value that's going to get displayed on the display. And then how to, well, yeah, I'll go through all the calculations. We'll see that in a second here. So in my analog pin tutorial, I talked a little bit about how the A to D converter does its work. And because we've got a resistor divider on the on that I/O pin, we can our desired voltage that we can read is 0 to 15 volts, and so that'll scale to 0 between 0 and 1023. Remember, 1023 is the biggest number that the analog to digital converter will produce. And so I can write a little simple ratio here. The raw value, V raw, is the same to 1023 as the voltage in is to 15. So it's a very simple ratio. These two are the same. Remember how I said that the analog to digital converter gives you a number in between 0 and 1023 that represents the ratio that the input voltage is to 15. So rewriting that, solving for V in, we have V draw equals 15 over 1023. Now, our calculation here might be better for the moment. I'm just going to change this here. I'm going to call it K for the moment, because we're going to have to manipulate some numbers here to get what we really want. So rewriting that, we have V in, which is the value that we want. That's the value that's going to get displayed on our display, is equal to V raw, the value that comes out of the A to D converter, times some number to get it into that format. Now, we could, if we want to, display 1023 or anything between 0 and 1023 on our 4-digit display. It would display nicely 1023 or anything else. But that doesn't mean anything to us. We want to have our voltmeter to read out in actual volts, not in the analog to digital converter numbers. So that's what this is all about. So we have to do a bit of math here to figure it out. So if I do this calculation, 15 over 1023, we get this number here, 0.01466. Now, if we were to put that value into K and did our calculations, we would come up with the correct value for voltage. But it would be would include a decimal point, and also this, well, yeah, with the decimal point in here, and we'd also get a decimal result out. And what's going to happen there is if we try to code this, the compiler is going to look at it and say, oh, we've got a decimal point here. I need to bring in the floating point math package. And floating point math has a huge cost in these microcontrollers. It takes up a very large chunk of memory, and it's long. It takes a long time to compute these numbers. And so I want to avoid bringing in the floating point package. And I'm going to do this with what's called fixed point calculations. And so I have to fudge some numbers here. I shouldn't say fudge them, but adjust the numbers so that we can get everything to work out in the end. First of all, I want to get rid of this decimal point. So if I multiply this by 100,000, I get 1466. So that'll be our value for K. So what's going to happen here, I'm going to do some calculations so that when I get a V raw that's 1023, it'll correspond, when I do the calculations, I'll get 1500 out at the end. And that's a nice number here, because remember, 1023 corresponds to 15 volts in. So that gives us our 15 volts with the 2 decimal places. So the decimal point is implied. It's here, but I'm not using a decimal number. I'm using a whole number, 1500 here. And so any number between 0 and 1023 is going to give us a number with 4 digits. It's actually going to go beyond that, but we're only going to be interested in the upper 4 digits. What I need to do now is, remember I talked earlier about a variable that we need to store the result of this calculation here. Vn equals V raw times K. These are big numbers. And so when I do this multiplication, and I'm looking at the worst case where V raw is 1023, it's the biggest number, we multiply it by the K of 1466, and we get this number here, which is huge. It's 1.5 million. Let's put some commas in here to show you how big it is. Now, I need a variable Vn that's big enough to store 1.5 million. So if I use a byte, the biggest number I can store in a byte is 255. So that's not big enough. The next type of number that the C language, programming language, recognizes is called a word. And that's 2 bytes, 16 bits. And 2 to the 16th allows me, the biggest number I can store in 2 bytes is 65,565. 65,000 is still quite a bit less than 1.4 million. Now, if I were to, the next variable at size that's recognized by C is called long, and it's 4 bytes long, which is 32 bits. And when you do the math, the biggest number you can store in there is something like 4 billion or something like that. I forget the value, which is longest, which is certainly big enough for this 1.5 million that we're going to get here. So when I declare this variable, I have to tell the C programming language how big I want it to be. And so I'll tell C that VN is going to be a long. And I'll get into that in a bit when I start actually looking at the code, how to write it. So when we look at this here, it's a big number. We don't need all these extra digits. We're going to chop off these ones here, and we get 1499. Now, I'm going to apply some rounding here. So you know how to round. We want to round to this digit here, this 9. And in order to round to 9, we have to look at the next digit, the 7. And is 7 greater than 5? Then we add 1 to 9. If 7 is, or this value here is less than 5, then we don't change this. And a simple way of doing that before we truncate it is we simply add 500, just a number with 3 digits. So we'll add 500, and that will give us a number, and I'm not going to do the math here, but what will happen here is this 9 will get incremented, and this will become 1500 with some stuff after that, and then we're going to truncate that out, and we're just left with the 1500. To get our 1500 here, we want to move the decimal point back 3 places, so we just simply divide by 1000, and our answer is 1500. So our calculation, in order to convert VN to VRAW, or VRAW into VN, is using this thing called K. And what I'll do, I'll write out the whole equation here, including the truncation. So VN, the final value that we're going to display, is equal to VRAW times our value of K. And I'm just going to go back to here. We're going to call this 500. I'm going to give it a value, or a variable called R, or a constant called R. So we take VRAW, multiply it by RK, and let's make sure this is centered here. It is. And then we'll add 500 to it, and then we'll divide the whole thing by 1000, and that will give us our VN. Now, our VN, we'll just say for the moment equals 1500, just for the sake of argument. Now, what I need to do, remember, this is stored in a very large variable. It's called a long with it's 4 bytes long. I want to take each one of these separate digits and put them into a separate byte called digit. What did I call them? I have to look back in my storage here. Digit 0, display digit 0, 1, 2, and 3. So each of these are going to be a byte. They don't need to be that big because we're only going to store a number in them between 0 and 9. And so I want to put this 0 in display digit 0, this 1 into display digit 1, display digit 2, display digit 3. So in order to do that, I have to do 2 operations. One is called divide, which we're all familiar with, and the other one is called div. And what that means is you do the division, but then you throw away the result and you keep the remainder. So I want to get this value here. So I take our value of Vn and I divide it by 1000. And that gives me 1. And if this was 500, that would give me 0. So this, well, I'll just do this. This one goes into display digit 3. Now, I need to get the result of this, the rest of it, after I do the division. So I go Vn Now it's a different symbol. It's not that slash. It's actually a percent sign. 1000. And that gives me 500. Now I want to get the 5 out. So I take this and I divide it by 100. And that result will then go into display digit 2, the hundredths digit. I repeat the calculation again because I want now to get this digit. So I do all of this. Anyways, do all of this. I'm just going to call that a blob, and which is this stuff here. And what do I get? I get 5 out of there. So I want to get this digit here. So I divide by 10. And that goes into display digit number 1. And then finally I do blob again, but div 10, and I get the last digit. And that goes into display digit 0. And I'll have it all detailed out in the instructions, in the code. That is how we design our software. You've noticed that I have not written a single C instruction anywhere here, but I've got all of this documentation here of the functions and the variables and the pseudo code, if you want to call it, the overview of how this software is going to work. And now I want to go to the actual software and start writing it. So next we'll show you that.